Buongiorno, sono Juan Carlos de Marti.
Good morning, I'm Juan Carlos de Martin. I'm a professor in computer engineering at the Polytechnic of Turin, and I co-direct together with Marco Ricolfi the Next Center on Internet and Society. My task today is to introduce one of the 6 great challenges or global challenges, as we called it and identified by the Polytechnic in the context of this important educational initiative. That is the great challenge of digital. What do we mean? We mean the digital technologies that have begun to develop from the mid-20th century until today. They represent, with the power, capillarity, importance, a challenge from different points of view. A challenge for the opportunities they represent, and they would like to take up a challenge for the consequences. Some of the waiting and wanting and otherwise unwanted that we should learn to know and to check, if possible, to eliminate. So this is my personal challenge for this lesson today. You will be following 4 parallel courses that will look at the great digital challenge from 4 different perspectives, also with the same approach, because all of these courses have the same type of approach. And you will look at from different angles at the great digital challenge. So these 4 courses that you already know, we have one called Algorithms and Democracy, held by Professor Stefano Sacchi of the Department of Management Engineering, who, in talking with a computer engineer, will explain how the use of algorithms, artificial intelligence, machine learning, and so on, so where they are applied in the context of public offices. So when these algorithms provide a certain public benefits. Then a second course in English, cybersecurity and national defense. It's held by Professor Paolo Prinetto, a computer engineering director of the CINI, the National Laboratory on Cybersecurity, who, with a co-teacher, as all these courses are organized, will clearly explain how the computer base is important and how other implications will be explored. And then the third course held by Professor Sara Monaci, it's Internet and Social Media Technologies on Communication, and then we'll talk about social media and other issues that we look at every day. And it will cover many phenomena and on which the attention of many has been focused in recent years. And then a fourth course that is one had by myself. It's called Politics and Technique. And we will talk about the reality of one of the most important relations of modernity, that is the relationship between technology and politics, therefore between those who develop technique in the broad sense of the term and those who instead decided democracy. And we do that with examples and reasoning and information related to digital technologies, precisely because we are in the digital challenge. So then the microphone will be passed on to these 8 teachers, 4 pairs of teachers, who will address these 4 specific angles. Clearly, this digital technology is a wide topic that we will be developing throughout the years. So the topic, as I said, is a huge topic. So we will talk about this just to give you a hint of issues that we will be looking at when we talk about digital technologies. I will be talking about 4 topics in order to create a base, a starting base for these 4 topics. So no request to provide a great fresco because we don't have that much time to do available today. So where to start? It's not easy to make an introduction of this kind. So I decided to do something a little different from the usual, because you have to know that in recent times, in the last months, to put order in my thoughts, I'm a computer engineer, and I began to be fascinated by computers when I was a kid at the beginning of the 80s. And over the time, especially over the last 20 years, I began to ask broader questions, but not also about digital technology and society. So I've tried to put order in these thoughts, who are increasing and sometimes contradictory, complex, and so on. Recently, I chose a path that it's a bit new for myself, but I found it useful and maybe fun. That's exactly what I would like to use today to introduce the topic, which is this is something unprecedented for an engineer like me. So what did I do? I tried to write a small poem that is called Digital Machines Interest Me. Clearly, it's made by an engineer, but it's a new way for a nerd like me to order some concepts, to order some facts, also to convey a synthesis of what I think I've understood in several years of studies, of comparison, also at the international level, and also giving some priority regarding some topics of such a great magnitude. This sort of serious and even little programmatic poem, it served me. It's my point of view, clearly. So what I'm interested in, it's my angle. But I hope that this exercise, which has been useful for me, can be useful for you too, to better understand the digital challenge, starting a little from the basics, to then go to the actual cases. And I'm sure you have been wondering, asking yourself these questions very often. So here's my proactive poema, Digital Machines Interest Me. You also can find it online. It's 2 pages. What I want to do is try, since it's very dense, I'll try to read it you line by line, and then I will comment it, and I will try to mention what is behind this, because there are many things. It gives the opportunity to think about many things. So I will read and comment. And so let's try to see what happens. So let's start. So digital machines interest me. Humans act. Humans have the characteristic not only of existing and vegetate, but also to act and satisfy their basic needs, hunting, farming, and so on. So it's not a coincidence that our species has, when I say our species, I mean Homo sapiens, as many scholars have defined, is Homo faber. That is the man who makes, the man who builds, and it's a fundamental characteristics of our species, even of the species that preceded ours. So those that came before, like Homo sapiens, Sanders, Neanderthals, and so on, and they give us examples of big objects built by man, and we are backdating more and more the starting point where man starts building. And usable examples of hunting date back over 1 million years ago, long before the arrival of Homo sapiens. So humans act. Some of their actions, like talking, singing, dancing, do not leave any material artifact. As we know, some of the things that we do are also important. And actions are actions where we use our body. I'm speaking now, so singing, dancing, also now that after the interaction, such an interaction, there is no object left, which in philosophy is called an artifact, something made by man. And these actions are beautiful action, very important actions and fundamental, but they're not the kind of actions on which we focus our attention, especially today when we talk about technique in general. Although some of these actions require a technique, because when you play an instrument, you say it has a good or worse or a better technique. So technique, the term technique also falls under this type of actions. But let's focus on other actions. Some of their actions shape atoms to bring beautiful things into existing. So some actions of the humans shape atoms. Let's stop here. They shape atoms. So the Homo Faber, the builder who builds objects of all kinds, not only digital objects, how does this man build? It's not creating from nothing. We humans create because from our environment we take atoms, substances that already exist, and using these atoms we build, we shape artifacts, objects. So this is the first starting point from which we could go towards many directions. For example, if we take pre-existing atoms, we do not create from nothing, and we model, we transform them, we melt them, we synthesize them, we work on them to create objects, artifacts, plastics, in carved wood, in silicium, and so on. It means there's a very close relationship between us and the environment, between us and the planet we live on. So it's a trivial thing, I know, but it's obvious. But we are from this word, we take from this word to feed ourselves. But most of all, we take to build the incredible amount of things that human beings have created, starting from their existence, and that we continue to build and to create, to put back into the environment. Every day, billions and billions of small, large, complicated objects. We take the atoms from the environment, we shape them, and then we put them back into circulation. To which end? To do what? To bring beautiful things into existence. So the first end, as I told you, dates back to very distant time, in deep history. We feel the need, not even also Neanderthals, and not only Homo sapiens, to create and shape atoms into beautiful objects for aesthetic purposes. And this is the first category that we have understood to learn over time to label with the word art. In Latin is ars, which has to do with, as a root, it's a root to many words. Think, for example, of artisan, of crafts. This is the first category. The second category, and also speaking of humans, some of their actions always shape atoms to bring into existence such things that help humans in their relationship with the spiritual world. Another category that dates back to the depth of history. That is, we take atoms, we shape them to create objects. which somehow express our need, our desire, dialogue, to represent, to interact. A world that is not necessarily visible and tangible. This is the world of animism. There can be many other religions. Humans for a long time, they've also had this specific purpose. Then the interaction with the spiritual world can produce beautiful objects, but they have these specific functionality. Then in the third category, we are getting close to the object of the Polytechnic world. Some of their actions shape atoms to bring useful things into existence. So things that are needed to do something typically tangible, actual, concrete, a chipped flint, bow and arrows, javelin, screwdriver, a computer, a camera, and so on. Useful things. Pay attention, because the word useful, it is used in a technical sense, in the sense that it's not necessarily a positive connotation. Useful can also be the atomic bomb. Useful in the sense that they get a certain effect. So this first of the action shape atoms to bring useful things into existence. We could say that the Polytechnic, not only the Polytechnic, but certainly the university called Polytechnic, and more precisely an higher education institution that studies and teaches the most modern techniques to bring into existence useful things. Bridges, roads, computers, water systems, and so on. And there's also have the engineering side, and then the architecture side, with all the other disciplines like urban design and so on. So, among useful things, we have digital machines. So men act, some actions do not live artifacts, do not produce artifacts. They don't stay in the environment. They're wonderful, but they happened, and then only the memory stays, or like a vibration in the air. But other actions produce tangible things that remain in the environment. So, in the category of the things that remain, there are useful things. We have among these digital machines. So, digital machines have used this this broad expression. So digital, that they manipulate, that underneath they make calculations. By doing so, they can manipulate different symbols like letters, pixels, and so on. You have started all digital disciplines, and you've started probably doing a digital program, but also everyone has a daily experience and an experience with what digital means. But they are machines. So machine is the broadest term within which fall different types of machines, including digital machines. There are electrical machines. Digital means electricity, and under category electrical digital machines. So, what do we say about these digital machines then? I go back to the verse. Digital machines are increasingly involved both in human actions that do not produce artifacts, and also in human actions that bring to existence beautiful, spiritual, and useful things. So the first observation is that today, 2022, now the second century advanced, we record that digital machines in their current evolution are therefore more powerful, and they're increasingly involved in all human actions. It's not necessarily mandatory. We record that if I dance, play, sing, first category, if I do beautiful things, if I do spiritual things, if I do useful things, digital somehow is involved, even if the end result, the final result is not a digital machine, because I use digital machines to do these things. Or even in the case, in the weakest connection possible. Suppose I'm dancing. This dance is increasingly, it happens more and more often that is recorded digitally. It's not as it was done 100 years ago or 1,000 years ago, but it's recorded digitally, or the training of dance. I use digital didactic source. So all human actions are involved. A second observation. Digital machines are increasingly embedded in beautiful, spiritual, and useful things, the three categories we spoke of, by hybriding them, by turning them into cyber things, cyborgs. So digital machines, but also even if they are not digital, they're becoming digital. For example, take the machines of the 20th century, as was the car. The machine of the 21st century is the smartphone. So a few years ago, this car, 100 years ago, the car didn't have anything of digital. Then it started little by little to have on board digital equipment, and now it has a lot of digital. Dozens of circuits of onboard microprocessors that handle various aspects of the operation of the car. And this didn't, when computers existed, then to the progressive miniaturization, the reduction of car costs, increased performance. Instead, digital has entered powerfully into the car. Now we see some plants have slowed down, and now they're even closed because they're failing digital integrated circuits. But not only cars. All of us will know about some objects that were not digital and have become digital because they've incorporated, they brought on board small computers that add features that are evidently considered interesting. So think about smart street lights. Smart, this small word, smart, shows that a computer has arrived. How smart the action of the computer is, we still have to check, but this is how it works. So everything is being managed by a computer, even objects that were previously non-digital. Let's move on. Digital machines are increasingly physically attached to the bodies of humans. They monitor the organic state and the environment in which they are immersed, influencing human behavior in the first. And in the previous verse, we said the digital that goes to hybridize objects. Objects that perhaps for a very long time until then had never been digital. And we're now talking about the relationship between digital machines and humans. But digital machines, let's go step by step, they're more and more physically attached to the bodies of humans. With this, we mean the fact that computers are born as big, expensive, they were expensive noise machines. They used to fill an entire room. First, during the 40s, 50s, 60s, computers were huge, and then they became smaller and smaller. They came to stand on a desk. We still talk about desktops, computers. And then they become so small that we could put them on our laptops or notebooks. And now we know the most widespread computers in the world that are the so-called smartphones. Therefore, an object that is something that has something of the old first generation mobile phones, but which in fact have become computers that also make phone calls. They're so light that we can always carry them with us, always close to our body, in our pockets or in a bag that is not so far away from us. So it's an object that it's not totally close to the body, but it's not just a smartphone. We have smartwatches, wristwatches that become to spread during the First World War. At that time, or 100 years ago, they were mechanical, but now they become digital, and they are small computers, and those have the characteristic of being constantly in contact with the human body, and therefore can constantly measure the heartbeat and many other vital parameters. The more time passes, the more they measure. That's why I say monitoring the organic state of human beings and the environment in which they are immersed. So the smartphone watch is my smartphone, and the smart things I have on me measure the ambient brightness, measure the noise level, measure the speed at which I'm moving. And I add and wrap up influencing human behavior, because these machines can give directions to the owner about these objects, modify his behavior from many points of view. It's a broad topic, but I think it's also an intuitive one. If I tell you that the smartwatch you have in your pocket changes your behavior, even just with notifications, because you get information on your smartphone, and then while you walk on the street, you suddenly stop and decide to go elsewhere, or you see that the tramway is coming, you run so you don't lose it. So there's a flow of interactions and feedback between the human being and the digital objects near your body that has deep impacts, and also come to higher levels of abstraction, and are always more complex than the kind of information we read, which shapes our worldview and modify our political, economical behavior. Let's go on. Digital machines shape like other technologies in the past, but probably with more pervasiveness and more intimacy, what human beings perceive, think, and feel. This is what I started telling you a second ago. It's not the first time that machines have an impact of what humans perceive, think, feel. What I argue is that the level of capillarity, of intensity is new. Let's talk about, make an example of machines that have had an impact, or a technology that has more impact of the way humans perceive. Well, think about writing. Writing is a revolutionary technique, a disruptive technique. Doodles on a piece of sheet, a papyrus, a parchment, that are interpreted by those who can read with a sophisticated and wonderful process. We interpret these signs on the support. We interpret this technology, and it can have an exceptional, gigantic impact on what we all know, what we perceive, what we think. It's not machine, it's a technique, writing. Now think about the huge change it had on this technology the invention of movable type printing around the middle of the 15th century. Gutenberg in Germany invents this technology, and it is estimated that 50 years after Gutenberg's invention, a huge amount of books was printed within 50 years. So think of the impact that technology had on what human beings perceive, feel. Or think about humanism, think about the Protestant Reformation with Luther and so on. Until up to more recent times. Think about the impact of the radio, the impact of rotatory presses, that newspapers were printed throughout the night and then sold in the morning, and then they increased little by little until they reached a number of hundreds of thousands of copies being printed each night. So, some daily papers were printed in incredible numbers thanks to the machines. And then a few years later, the radio. Today, this year, 2022, exactly 100 years ago, the first radio station was opened. So the first radio station with a specific frequency, with an identity, with a program, 100 years ago. And immediately they understood how powerful this tool was. So that year was the first public speech of a president of the United States. Until today, and repeating the verse, you will better understand, I mean that digital machines, smartphones, computers, and so on, shape like other technology in the past, with more perceivedness and more intimacy, what human beings perceive, think, and feel, and is therefore a process that started with various techniques, and which, however, sees a new phase, especially with the smartphone. 6.5 billion people with a smartphone all over the world. A clear majority of humanity with a screen that turns on, shows things, shows images, news, suggestions. Let's move on. Digital machines are increasingly mediating the relationship between every human being and the rest of the world. Again, the thought goes above all to smartphones, obviously also to computers, to laptops. So they, by mediating the relationship between every human being and the rest of the world, especially after 2 years of pandemic, it means that my interaction with the environment where I am, let's think about Google Maps or other maps that have to do with the environment, or an app that tells me the usual stops if the public transport is coming, or the weather forecast for the next hours, or apps with which interact with friends, or the university I go to, or apps to buy items, to order food, and so on. So what I mean is they are increasingly mediating the relationship of every human being with the rest of the world. First, there's a more direct relationship, maybe it's more inefficient, less pleasant, and so on. But the thing is that there's someone in between, a mediator, that stands between me and the various aspects of the world. And every time there is a mediator, an intermediary, a set of questions opens up. So, if between me and the other thing, or the other person, or the other service, is there anyone in between? So this one in the middle acquires a power. So I will teach you this power, politics and technique. This is a power that automatically opens up a number of questions because the power can be exercised more correctly, less correctly, in favor of someone against someone. So digital machines are increasingly mediating the relationship between every human being and the rest of the world. A little longer verse. Digital machines, for the most part, are not collectively governed. Most humans, in fact, limit themselves to using them and are used machines designed and controlled by few. This is the first sentence of this verse. It's more dense. I'll stop here. These digital machines, in reality, like basically almost all the technologies we use, new, old, brand new, and so on, very old and so on, they are not collectively governed. We don't decide collectively how they're made. So the typical smartphone that we have in our pockets, we did not decide together in any way we could do it. If such a powerful object has or does not have certain features, and most of us, the vast majority of us, use and is used this sentence, machines designed and controlled by few. So many of you are doing an engineering degree course. I could say myself, from the strictly technical point of view, there's few people who design them. But what we tend to forget is that, one, there could be more people who have a say in the project. For example, we could say a specific sensor among the many those that we have on the smartphone is too intrusive. Maybe we should remove it. For example, like tools that are made available by the majority of democracy, but this doesn't happen. So this potential, this possibility is never there. But these are machines controlled by a few. By a few, what does that mean? Well, here I refer to a topic that you will find in the courses that you will follow downstream this introduction, and that maybe I will still be able to touch today. However, in a nutshell, if we go and see who really controls these devices, we realize there are very few actors who have a great control over these machines. In particular, I also focus on this not only because of its importance, but also for the convenience of presentation on the smartphone. Who controls the smartphone? I'll give you one data. Smartphones are computers to work in a way that is, how can I say, easy to use, have an operating system. Many of you have a computer with Microsoft Windows, or some of you use Apple. Well, smartphones are computers, and even these computers, they have operating systems, and these operating systems are two. There's a duopoly. There's a vast majority are an operating system called Android, owned by Google, and there's iOS. That's the operating system by Apple. So those who control the operating system have a high level of government, of control over the smartphones, and it's two big North American companies, Apple and Google. It's a real-life example. 2 years ago, during the first lockdown, so we're talking about April 2020, there was a lot of talk about something that it fell into oblivion for many reasons, and almost that is the tracking of contact supported by an app on smartphones. That's digital contact tracing. Since the modern treatment of epidemics has existed, we try to do contact tracing to trace who the people we have come into contact with. So if you think correctly that since we all have a phone, this phone can be used to be at least a support to contact tracing. Well, governments dive into this. Many governments like in Europe, France, Germany, Italy, England, they're looking for a solution, for a simple, relatively simple solution to this gigantic problem that the pandemic was. And they discovered that they cannot do what they want to. They cannot put onto the smartphone what they want. They can do only what the operating system allows them to. The two operating systems that are operated by Apple and Google. So there was a very hard clash between some governments because these two companies decided that it was not desirable. So they didn't make the changes to the operating system. And since as regarded Apple, there was also the store control, so the possibility of rejecting any government app that was not online with their own. I'll stop here because these are topics that are partly expanded into another area. So let's go on with the verse. However, the few who design and control that they own use the most powerful digital machines on the earth. What do I mean by this? I allude to the fact that we think about the computing power. Where is it? It systematically coincides with those who design and control devices. The so-called big tech, the big tech companies, Facebook, Microsoft, Google, Apple, and so on. They own the large data farms that allow you to offer services with high quality features. And then I would say also some governments like the United States of America that have their own great calculation computing powers for mass surveillance or espionage and so on. So the same few who use and often own the data produced by many. So if we ask ourselves where the computing power is, we ask ourselves, where are the data? Always the usual ones. Not only from them. I'm sure there's even large communication operators, large banks have a big amount of data. So it needs again concentrated, maybe a little bit wider compared to the previous points. But if we were to make a map, if there was a map that provides a visual of where data are concentrated, all the computer architecture of the computer world is built to continue to fit this concentration. If you see how the way how software is built, our smartphones and computers, it's built to act as a bottleneck and to collect data and bring it to digital farms, to digital factories, to digital farms of Apple, Google, Microsoft, and so on. So it's our choice to decide where we want to send them. We often give up to the lure of sending them to the center because it's more convenient. Sometimes we pay them you pay storage services and so on. So let's go on. So how are digital machine born? Am I interested? So in the last part of the poetry, all the verses have am I interested in? So it's my list of the priorities, which is incorporated into this sort of text, and I present it to you because these represent my personal interests, but they also correspond to the interests of a wide spectrum of researchers, scholars, intellectuals, politicians who focus their attention in this direction. So, how are digital machines born? Am I interested in? And who decides to produce them? Who plans them? Who designs them? Which elements are involved in production? Who produces these elements? And who physically builds these objects? Who transports them, sells them, repairs them, and under what conditions they do these things? So here, in a handful of words, we have a vastness of research projects. Many of them are sociologists and many other figures who are just shedding light on these things that I say they interest me. I read and study these things. Clearly, I cannot deal with everything with the same intensity, but I am interested. I try to say a few words of comment on each word. So, who decides to produce them? What do I mean? I mean, it's not in my powers or yours, but I have a certain idea for a certain digital camera. So the decision to produce that it will be producing thousands of millions of copies, it's not us. It's not my power. So I can write a little software. I can design a small prototype, but then if I wanted to do something more important, I wouldn't necessarily have to go to find the collaboration of many people, and this is complicated, or the main road in our system seems to be to have a financial availability, or we can convince someone to tell us tell them, give me some millions of euros because I need to do this thing. So it's a relatively small number, very small compared to the population. So who designs them? So here engineers come into play. This object that can be produced in large quantities and be efficient, robust, and so on. So designers, engineers, those who do the outside designing, elements that are involved in the production. So what does it take to produce them? So like I said at the beginning, human beings, Homo faber, when they want to make objects, they must take them from the environment. Humble things or very rare things, they build the object. Let's say wood, for example, maybe one of the oldest or rare soils. So which elements are involved in the production? This is a very important question. And one of the things that is super interesting to do, say, take a smartphone, and inside the object here, the elements of the periodic table are present. So who produces among the elements, in what conditions are physical elements, in fact, where they come from? Some are very widespread, others are only much less. Under which conditions they are produced. So those who produce asbestos or lithium, they are available in nature. There are mines, lithium mines. Where are they? How is the lithium extracted? How is the lithium harvested? And this lithium is a very, very important topic because this is essential to make modern batteries for electric cars, but they also go into an endless number of objects. So this, asking myself what elements we need, where they come from, who produces them, opens a view, an incredible views of an incredible number of environmental and geopolitical issues. Maybe 90% of rare earths are currently produced by China, and therefore it's almost a monopoly. Labor issues. Under what conditions are these elements produced? Not only the environmental impact, but also human impact. For example, let's think about coltan that is essential to produce computers. It comes from of the region of Congo, and it is quite easy to harvest. You just dig holes in the ground, but it's done in very dangerous conditions. But this is also done by children, so that's why we should wonder, how is it, who produces it? Now, thinking about machines, who physically builds and transports, sells, repairs digital machines? The factories. Think about Foxconn for Apple, who transports these machines around the world, China, Korea, and they're transported by ship, they're carried by ship. So they're humans that take them, these objects, they pack them, they put them in containers. Who sells them? In stores, online. Who repairs these machines? And all this in which conditions am I interested in? So you see how wide this interest is for a scholar. It's a political interest, environmental interest, and economic interest. What happens when digital machines stop being useful? Am I interested? Well, digital machines, like we said, are useful machines, but at some point, as you know, they stop being useful because they break, because there's no longer they're no longer worth repairing, because they become obsolete, or they don't work well as they used to do before. So digital machines, all digital machines, are machines that have a relatively short lifespan. So we produce thousands, billions. Smartphones is 1.5 billion smartphones sold in a year. So their average lifespan is 3 years. So what happens? How do we dispose of them? Who does it? In which conditions? And this is another gigantic environmental topic. So it's about possible recycling of some parts of the objects. It's also geopolitical, because a lot of this waste ends up in poor countries, and because it becomes toxic at some point, we pay them so they can take it, since these are poor countries. Let's move on. What digital machines do? Am I interested in? What do they do? But how and why? At what price? For whom? Against whom? Why they do it? Now we're talking about features, characteristics, functionality. So I have in front of me a digital camera, smartwatch, a smartphone. I wonder, what does it exactly do? Now, this question will have let's say, an obvious answer. It allows you to make phone calls, send messages, and so on. But some of the things that these machines do, that these machines have a hidden side. So they do things that are not at all clear to those who belong it. They're not explicit. So they do explicit things, but they also do implicit things, the things that the user doesn't know that are happening. The fact that there are, for example, brightness sensors on all smartphones. So no, my smartphone is turned off, but if I would turn it on, it would sense a very strong light in this room. So this information is automatically recorded, and the vast majority of people does not know what it's doing. and they don't know who uses this information. If the phone does not have many apps, and these apps have access and have the information in real time, but it's important to know, and it's important to know who does this, who uses this data. Knowing that I'm on a certain time of the day, that I can be located or understand where I am, or what kind of daylight there is. All these informations combined can provide an information to someone. So what does the digital machine do? Am I interested in? It's less. It's deeper than it seems. So why they do it, at what price they do it, for who they do it, against whom they do it. So 5 things, and each one opens up into many directions. So how they do it, so we as engineers can give a big hand in understanding why they do it. There's a specific sensor. Why was it assembled on the phone? Probably there was an original reason. Okay, let's think about environment, light. So because when we take the phone close to our cheek when we're talking on the phone, the light turns off, so the battery is saved. But there are also many others, less harmful, or at least less useful for the user. At what price? So what was the price of this function? And then we say, and then for the benefit of whom? Who benefits from it? Obviously, the official position is that we do it for you, for the user. It's a good feature for you. But it's not always correct. In more than one case, for a certain aspect, but from others, it is important for other aspects. So maybe it's because someone else needs it, and then against whom? I've added this because an essential component, essential part of relationships, conflict. There's no universal harmony where in reality we all agree and we have a same interest. There are certain things that digital machines do that are against our interest because they are someone else's interest. The vast surveillance, the vast amount of data collected, the smartphones collect about us, these are not for us. They're mostly used, very large parts, they're used by the companies I've already mentioned. Typically, they do it to sell advertisement, to sell products. So it's very weak, but it's there. And then we get another verse, and then we get to the conclusion. What humans do with digital machines, am I interested in? So we have digital machines, we use them. Sometimes we do it in an unpredictable, unforeseen, surprising way. It's interesting. Am I interested why they do it? With under which conditions? With which consequences? What humans would want to do with digital machines, but at the moment cannot do, I am very interested. This refers to the fact that we did not design digital machines, we do not govern them, but it allows us to do certain things, but what they could do and they don't do, probably they could easily do, because I'm interested, because it's the digital world that doesn't exist and I could be interested in. So here we talk about features that could be useful for the individual or could be socially useful. But since they have no market, they generate no profit. When there's no profit in our system, it's not developed, or maybe it could be very useful for the individual or for the collectivity. So the first step is, so what could it be? So let's use our technological imagination, because you, as future engineers, it is intrinsic to our role, not only to those who tell us, design this. You could also say, you know what, it could also be this way. So use your technological imagination. Something doesn't exist, but in our head we imagine that it could. And then maybe have the opportunity to really design it and bring it to life. So this is very, very important and interesting, because there's a gap, because techniques and digital machines, functionalities of digital machines have no market. And this is a hole, this is a gap in our system, because we tend not to develop it, even given the weak role that the state that it gives to it. Last verse that's connected with the previous one, what digital machines could do, I am very interested in. What could digital machines could do differently? Something they already do, but they could do in another way, or maybe they could not do at all. So something they already do, but if they do it differently, maybe it would be much better, maybe for the environment, for human rights, and so on. So, and in some cases, things that they don't do, but it would be better if they don't do it at all. For example, many scholars, activists that believe that facial recognition, especially in public places, streets and so on, should be forbidden, banned, not regulated, forbidden, for a number of arguments that we cannot deploy today. But this is an example of a feasible digital technology, but for a number of reasoning that has to do with civil rights implications, we could say this functionality, it's better if it doesn't exist. What digital machines have never done, but which they could do, at least in principle, for humanity and the planet, connected to what I told you before, that is exercising technological imagination. Ask ourselves, what could digital machines do that don't do yet? So this requires technical skills, because technical skills allows us to make allows us to use our fantasy, but we think about things that are technically feasible, because we have a good basis of technical information, and then we use it to move towards directions that until now have not been pursued. So this sort of poem, that it's a sort of a joke, as you've seen here, that talks about digital machines. I hope it has anchored the concept of digital thinking to the widest topic of machines. Digital machines are machines. These are reasonings that should be made over technology in generally. And then let's try to list a series of topics, of issues that obviously we will not deepen here in this lesson, but not even in the next courses, in the next lessons, because what I've listed here is the topic for a very high number of courses. So in the 4 courses that we will follow, we will address only some of the aspects that I've mentioned with this. But I hope I've given you somehow a taste of what we mean by great digital challenges. We could say I've listed a dozen possible challenges inside that the digital challenge. Okay, let's stop here for this first part. We will go on live, and then after the live period, after the break, in the second part, we will begin to give some further elements on something that has never been followed on this first part. Thank you.
Grazie.